Hi everybody, in this video we are going to work on solving one-step inequalities and multi-step inequalities. It's really similar to what we were just doing with multi-step equations, but there's going to be a big difference in how we kind of express our answer. So for starters, we're going to be filling in our blanks here, and it says sometimes there is a oh my goodness. Handwriting is not so great. All right, so sometimes there is a continuous range of possible values to describe a situation rather than a single answer. In that case, inequalities can be used to represent the situation rather than equations. An inequality is a mathematical statement that compares, for example, two expressions using an inequality sign. In an inequality, one expression of the inequality can be greater or less than the other expression. So special symbols are used in these statements, and we're going to look at those special symbols in this box below. So one of the symbols we might use is just x does not equal y. So x is not equal to y. So the number of days in a week is not equal to 9. Another inequality sign might be x is greater than y. So x is greater than y. So we might just have something like 6 is greater than 3, right? Or the number of days in a month is greater than the number of days in a week. I've had students before say they have a really hard time remembering which one's greater, which one's less than. Some students have told me that they had a teacher way long ago that had like an inequality sign, and then they would put teeth in it, and it was like the alligator, and the alligator eats the larger value. You know, if that works for you, awesome, use it. I just like to look at the inequality sign, and I mean, I look at it in terms of like if x is greater than y, like I look at the sign and I say, okay, which one is bigger? Which side is bigger? It's opening up to the x, and so the x is bigger. Even if I read it, you can read that inequality from the y, and you would read it y is less than x. And so you're just reading it from that symbol, and you're saying, or from that variable, and you're saying, okay, y, and then the smaller side is pointing towards it, is less than x. And so you can do it that way too. So if you want to do alligator, you want to read the sign, I don't care, just make sure you get it right. Okay, so the next one, the inequality x is greater than y can also be written as, that's what we were just talking about, y is less than x. The sides of any inequality can be switched as long as the inequality symbol between them is also reversed or switched. So that's just saying, like on this, you know, if we go back and I say, well, I want to flip-flop those two, then it's going to be x and y, but then you've got to reverse that symbol to be x is greater than y, just like it started out saying. The next symbol is just going to be x is less than y. So the number of days in a week is less than the number of days in a year. And then we've got x is greater than or equal to y. So is greater than or equal to y. So that one here is 31 is greater than or equal to the number of days in a, guess what, a month. So again, that's just saying if x is greater than or equal to y, x can be as big as y, or it's going to be bigger than y, is what that inequality is stating. And then the last one is going to be x is less than or equal to y. Less than or equal to y. So example, the speed of a car driving legally in a 25 mile per hour zone is less than or equal to 25 miles per hour. All right, so again, that's just saying X can be as big as Y, or it's gonna be less than Y. And guess what? We're also gonna be graphing these guys. So let me get out my next piece of paper. So this is going to be one of those, a couple of those paragraphs in your notes you're probably going to have to come back and refer to when you get ready to do the graphing for these things. So solution sets to simple inequalities. And I don't want you to think of this in terms of simple, like, oh, simple, it's so easy, it's simple. We're talking about simple versus compound inequalities. So a compound inequality is where you're going to have two different constraints on the end. And we used to do compound inequalities in this class, and now we just stick with the simple inequalities. So that's why we inserted that word simple. All right, so solution sets to simple inequalities can also be represented on a number line. Trying not to yawn again. First, let's take a look at the symbols we will use on the number lines. So each of these graphs begins with a circle. So it's either going to be an open or a closed or shaded circle. So it's either going to be an open or closed circle, which is going to be shaded in. This point is often called the end point, is what I think it's going to be. Yeah, it's going to be the end point or the critical value. This is what I use a lot. That's critical value. I use this term quite a lot. I'll say, what's the critical value? And you need to know that what I'm talking about is I'm talking about the end point of our solution set. A closed or shaded circle, let me find my space in here or my spot. A closed or shaded circle is used to represent weak inequalities, which are greater than or equal to, and then we're going to put our little symbol in here, greater than or equal to, or less than or equal to. And the endpoint is included in the, I have a feeling it's gonna be solution, in the solution. An open circle is used for strict inequalities, which are gonna be strictly greater than or less than. So greater than, so we're gonna have greater than or less than. The endpoint is not included. Are we gonna be able to fit that in there? Not included in the solution. The graph is then going to extend endlessly in one direction. So it extends infinitely in one direction. This is shown by a line with an arrow at the end of it. So this is just talking about how to graph these guys. I'm gonna move that up. The other way we're going to express our answer is in interval notation. So interval notation can also be used to express the answers of our inequalities. We can use brackets. I'm gonna put this one on over here. So brackets are used to indicate that a value is an endpoint of the solution set and that it is also included in the solution set. Parentheses are used to indicate that a value is not, I have a feeling it's gonna be not included. Okay, not included. To indicate the value, wait a second. I think that's the next part. Oh, endpoint. Parentheses are used to indicate that a value is an endpoint, sorry. endpoint of the solution, but not included. That's where the not included goes. But is not included in the solution set. The infinity symbol which looks like this, is also used when a solution set extends towards positive or negative infinity. So if it's negative infinity, we would actually go negative infinity, right? So positive infinity looks like that. Negative infinity is going to look like that. Only parentheses oh, that should be an E, parentheses. So should this one over here, wherever it is. Where did I do that? Parentheses, that's parenthesis. That should be an E. Can't have a typo in there. Okay, so only parentheses, never brackets. Don't do it. Never ever do we put brackets around parentheses or around, I'm having a hard time today, around infinity symbols. So parentheses ever only go around our infinity symbols. And that's what we're gonna fill in here, infinity symbol in the interval notation. Oh my goodness, that was a lot of blanks to fill in. Here we go. So here's how it breaks down. Like in this table, we're gonna talk about the symbols versus the number line graphing symbols and then the interval notation symbols and how they all line up. So for example, here's our inequality solution. If I had x is greater than 1, then if I'm putting that on a number line and I'm graphing it, we're gonna do a line here. That's my graph. And then I'm gonna do 1, which is gonna be here. And then I'm gonna do 0 and I'm gonna do 2. So I'm gonna have you do an integer value on each side of your critical value. Remember, this is your critical value or your endpoint. And if our solution set's gonna be greater than 1, we're gonna have an open circle at 1 and we're shading to the right towards positive infinity, and this is negative infinity over here. Then in terms of interval notation symbols, so look at your solution set. This is something when I encourage my students to think about like a little person walking along this number line. And they're walking, they're walking, they're walking. The first part of the solution set is gonna be here at 1. And then you have to determine, is that gonna be a bracket or a parentheses that goes around the 1? Well, the answer to that is 1 included in your solution set? And the answer to that is it's not. It's not included in your solution set, so it's a parentheses. So it's going to be parentheses around 1, and then how far to the right does your solution go? It goes up to infinity. So your little person is traveling along your number line. The first part of the solution is at 1 with an open circle, so it's parentheses, all the way up to positive infinity. And again, parentheses, never ever brackets go around infinity symbols. So it's going to look like that. So then the next one, we're gonna try like x is less than negative 1/3. So we're gonna do x is less than negative 1/3. I'm sorry, you're gonna have to kind of squeeze it in there. Note to self, I need to give you guys more space on this. So we're gonna do -1 on this and a 0, and then you're gonna place the negative 1/3 about where negative 1/3 would be. I'm also gonna put it here, negative 1/3, and I'm going to put an open circle at negative 1/3. And it says my solution set is less than, and so that means everything to the left. So then my solution set, think about your little person walking along it. The first part of the solution that they hit is negative infinity. So it's going to be negative infinity on up to negative 1/3, and you have to decide, are those parentheses or are they brackets that go around it? Here it should be parentheses, here it's also parentheses because our endpoint is not included. All right, so I'm gonna bump down to this second line. The next one I'm gonna give you is x is less than or equal to positive 1/5. And then so filling that in, we're gonna have our number line. And then that's going to be in between 0 and 1, right? So then 1/5 is going to be about right here. I'm filling that in this time because of this symbol, because it can be less than or it can be equal to 1/5. So here I've got 1/5, and you should ask yourself, is that shading to the left or shading to the right? Well, it's everything that's less than 1/5. So it's going to be shading this way. So then for our solution set, it's going to be, again, think about your little person walking along the number line. It hits negative infinity first on the solution. So it's going to be negative infinity on up to 1/5. And then this is going to be a bracket this time because it's included. And I'm just going to show you, I'm not going to draw it again, but if we did greater than 1/5, greater than or equal to, it'd be the same thing, except we'd have this, we'd have 1/5, and it'd be shading this way. And then we'd have 1/5 on up to positive infinity for that one. And then I would also still have you put a 0 and then a 1 over here too, to finish that out. All right, so what I would like for you to try is I would like for you, having seen the examples up here, what I want you to do is to try these. Try 1 and 2 on your own, and I'm going to do number 3 with you. And so what I would encourage you to do for number 3 is flip it around first, and we're going to say x is less than or equal to -4. So flip it around, because honestly, I feel like if you leave the x over here, you end up graphing it the wrong way. So here it says, graph the following solution sets and express your answers in interval notation as well. So here we've solved our problem. We get all the way down to the answer. It's x is less than or equal to -4. Let's graph it. I'm going to have you do -4 in the middle, -5, an integer value on each side. Is it an open or a closed circle is what you should be asking yourself, because it's less than or equal to, and you should be saying it's a closed circle. And then which way are we shading, left or right? And you should be shading to the left because it is less than or equal to -4. So then for our interval notation, think about your little person walking on your graph. It hits negative infinity first. It's going to go all the way up to -4. It's going to be a bracket because we've got a closed-in circle there. So our critical value is included. So for these problems, I just want to point out that when I ask you to give me 3 different solutions or give me the 3 solutions for your inequality answers, this is your inequality answer. This is your graphing answer. This is your interval notation answer. So that's something that students will ask me, like, I don't know what you mean by inequality. Well, this is your inequality answer, right? It's written as an inequality. So this is your inequality answer. There's your graphing. There's your interval notation. So I want you to try 1 and 2 on your own and see how you do with that. Then on the next page, we are going to do, next 2 pages, we're going to do some examples of solving multi-step inequalities. All right. So for our blanks for this one, we're going to use the same process, solving inequalities, as we do for solving equations. We're going to isolate the variable. Isolate the variable. So do the reverse order of PEMDAS, but using the inverse operations to undo the inequality. There's one very important exception, though, that's different from solving equations. Otherwise, the process is the same. You do the same thing as you do for solving equations, except for this. Don't forget it. So it's coming up right here. Circle it, box it, highlight it. Whenever you multiply or divide both sides of the inequality by a negative number, the inequality sign must be reversed in order to keep a true statement. However, if you add or subtract by a negative number, the inequality stays the same. So it's talking about like this. Negative 2x is less than or equal to 10. If we divide both sides by negative 2x, math siren should be going off in your heads. You're going to flip that sign, and it's going to be x is greater than or equal to negative 5. That makes sense too, right? Like if we say, let's put the 10 on this side, and we say it's greater than or equal to negative 2x. We divide both sides, so it doesn't matter. We're still going to get negative 5. We'd flip that. Is going to be less than or equal to x. So I just want to point that out. Regardless of which side your x is on, you're going to flip that inequality sign, right? Okay. So our examples here. First one is going to be easy peasy, lemon squeezy. We're going to do our warm-up lap around the track with this one. 4p plus 5 is less than 29. Ready, set, go. Solve it. So we're going to subtract 5 from both sides. We're going to have 4p is less than 24. Now we're ready to divide both sides by 4. And p is less than 6. And that's our answer. Okay, but how are we going to check it? Because you have to do more than just check the one value, because this solution set says that my solution is less than 6. Anything that is less than 6, it can't be equal to 6, it's less than 6. But here's what we do for our check. We have 2 checks. We're first going to check the critical value, which is going to verify that our critical value is correct. So this is checking that this is correct by plugging that in. So checking the critical value means you plug the critical value back into the original equation, and then you're checking. This is like our little algebraic check. And we get 24 plus 5, is that less than 29? Well, you might look at this and go, Liz, that doesn't make sense. 29 is not less than 29. That's true, and I'm glad you know that, and you're recognizing that. But what that means is that 6 is correct. That tells us that our critical value that we got is correct. The next thing you have to check is check a number that is within your solution set. So like when we're graphing this, so this is a 6, this is a 5, this is a 7, it's going to be an open circle, and we're shading to the left. What's a number that is in our solution set that would be super easy to check? And I'm hoping you say 0. So a 0 would be super easy to check. We're going to do 4 times 0 plus 5, which is less than 29. And so 4 times 0 would go to 0, and 5 is less than 29. Is that correct? Yes. So what that tells us is that we also didn't screw up our inequality sign, so that is correct. If you got this statement that 5 is greater than 29 at the end, what that means is you screwed up your inequality sign, and you need to come back here and flip that inequality sign. That's what that would mean if you got an untrue statement at that point. All right, let's try another one. So our next one is going to be 15 over 2 plus x, which is going to be less than or equal to negative 37 over 4. All right, try it. What would we need to multiply every single term by in order to clear our denominators? You could also, if you wanted to, subtract 15 halves from both sides. If you want to mess with fractions, go for it. I'm just going to go with the way of clearing your denominators in here. So the 4s are going to cancel out. Here, this is going to be a 1. This is going to be a 2. So then I've got 30 plus 4x, which is going to be greater than or equal to negative 37. I'm going to subtract 30 from both sides. And then I've got 4x, which is going to be greater than or equal to negative 67. I'm going to divide both sides by 4. And x is going to be greater than or equal to negative 67 fourths. That's not very helpful for graphing. So I want you to convert that into either a decimal or a fraction if it comes out to like a terminating decimal. And this one does. This one would either be negative 16.75 or it's going to be negative 16 3/4, right? So then we are going to graph it. So here's your graphing solution. So negative 16 3/4 is in between what two integers? And you should be saying negative 17 and negative 16. It's closest to negative 17. So we're going to do a closed in circle. This is negative 16 3/4. We are shading, again, it's x is greater than or equal to that. So it's anything that's larger than this, we're shading to the right. And then our solution set is going to be closed, or it is closed, but it's going to be a bracket because it's a closed circle. And it's going to be negative 16 3/4, and it's going to go up to infinity. And then it'd be parentheses around that. Okay, so if we were checking our answer, the check, we would be plugging in the critical value here. So this would be negative 16 3/4. And is that greater than or equal to negative 37/4? So when I plug that in, and I'm going to do this in my calculator, and I'm just going to do 15 fraction button, which is 7.5, right? 15 fraction button 2, and I'm going to subtract 16.75 equals. And then I'm going to put that back into a fraction, which is going to just give us, right, like negative 9 1/4. And you can ask yourself, well, does negative 37/4, is that going to give me 9 1/4? Yeah, because 4 goes into 37 9 times, you've got 1 left over. So these are going to check out. What is a number within our solution set? So this is us checking the critical value. And then another check on the inequality. What is another number we can check that is going to be super easy, that is in our solution set? And guess what? We can check 0 again because it's going to be in our solution set way over here. So you could do that. And you could say, okay, 15 halves plus 0, is that going to be greater than or equal to some negative number? Yes, because this is positive, this is negative. So yes, that one checks out too, that we did that right. All right. We're going to do a few more examples and then we will be done with this topic. So example number 3 is going to be 1/3 times x plus 3 plus 1/2, which is going to be less than 9 halves. So here, what I would urge you to do is to go ahead and distribute here. So we're going to have 1/3 x plus 1, right? Because 1/3 times 3/1 is going to give us 3/3, which gives us 1. And then we're going to have plus 1/2, which is going to be less than negative 9 halves. So what I would suggest you do, because I'm already looking at this and that we have a half and a half, you could totally multiply everything by 6 if you wanted to. But I'm looking at this, and this is going to work out really nicely. So if we've got 1/3 x plus 1, and we've got less than negative 10/2, negative 10/2 is just going to give us negative 5. So we're going to get negative 5, and you're going to subtract 1. Man, I'm writing big, and I'm not leaving myself a bunch of space for the next ones. So we're going to have 1/3 x, which is going to be less than negative 6. Now we're going to multiply both sides by 3 to get rid of that. And x is going to be less than negative 18. So for our graph, again, we're going to have negative 18 here, negative 19, negative 17, open circle. We're shading to the left, anything that is less than negative 18. We're going to have a parentheses, negative infinity on up to negative 18, and it's going to be a parentheses again. Parentheses around the negative infinity because it's always negative infinity. And we always put parentheses around the infinities, whether they're positive or negative. And then it goes up to negative 18, and it is a parentheses around the negative 18 because it's an open circle and our critical value is not included in the solution set because it's a less than inequality. So we've got a strict inequality there. Let's try 2 more. One of them I'm going to give to you guys to do. What number is this for you guys? This will be 4. 4 for you. So number 4, the one that I would like for you to try is going to be 5, and then we're going to have brackets, and then 2, and then parentheses. 3 minus x minus 1. End of brackets, and it's going to be less than or equal to 27. So I want you to try that one. With this one, with nesting parentheses, you need to go ahead and distribute this first. Then you can combine your like terms, and then you're going to distribute that 5 into your next mathematical expression inside the bracket after you simplify it. So you should be doing that one, and then your answer at the end should be x is greater than or equal to negative 1/5, but I do want you to check it, and you should have 2 checks. You should have the check for the critical value, and you should have the check for the inequality. So you should have both those in there for that one. And then the one that I would like to do with you is going to be negative 5d plus 2 all over negative 3, which is going to be greater than 12. So negative 5d plus 2 all over negative 3, which is going to be greater than 12. So here's one option for you. One option is you can split it up if you'd like. And so you could do like this over this. And so then you'd have 5d over 3, because a negative over a negative is a positive. And hang on one second. I don't like the mess there. So you'd have a 5d over 3, because the negative over a negative is going to be positive, and then you'd have minus 2/3, which is going to be greater than 12. So you could do it like that, and then multiply every single term by 3, and then keep going. I'm going to show you a little bit of a different way. It's a little bit more efficient that you could also choose to do. And if you don't like this way I'm getting ready to show you, stick with this way right here. Okay, one option is to look at this. We've got our numerator here, and I look at my denominator, and I say, okay, well, I want to get rid of my denominator, so I'm going to multiply this by negative 3, and I'm going to multiply this by negative 3. So when I do that, my denominator cancels out, and I've got negative 5d plus 2, and then you just multiplied both sides by a negative. So math siren should be going off in your head, and you should flip that sign right there. So that's going to be negative, or multiply by a negative, so you need to reverse that sign to be less than. 12 times the negative 3 is going to give us negative 36. Now I'm going to subtract those two, and you get negative 5d is going to be less than negative 38. We're going to divide both sides by negative 5. And d, again, flip your sign because you just divided by a negative, is going to be greater than 38 over 5. And you can put that as a decimal if it comes to a terminating decimal, and it should. Or you can rewrite it as a mixed number. So how many times will 5 go into 38 evenly? And so it's looking like 7, because it'd be 35, and then we'd have 3 left over, which would be 7 3/5 for your answer. I just checked, we did do that one correctly. Then for graphing it, so 7 3/5, we want to put that in between 7 and 8, and 3/5 we'll say is about right here. It's going to be an open circle, 7 3/5. We're going to be shading to the right. And then our interval notation is going to be parentheses because it's matching up with the open circle. And then it's going to be 7 3/5 all the way up to positive infinity. And then that's going to be the end of that problem. So thanks for tuning in. That's the end of this topic too.